So we talked about the terminology that's involved with calculating power. Again, ultimately trying to get to this engine output and how we measure the horsepower or the power output from our engines. So what we're going to do in this video is a number of examples of how we do those calculations. And we're actually going to do calculations a little differently than a lot of people might be used to doing it. We always like to have an equation that we can just plug numbers into it and spit out an answer. We're going to learn how to work with the units in these calculations, because I'm going to show you some ways that you can really get in trouble. So stay with me. This is going to be a new learning experience, a new way of doing the math that's involved in these relatively simple problems, but it's something that's very important to help us do a good job long term. So how do we get after this? So let's do an example, and we're going to start actually with a linear power example. And we're going to start, we talked about how power could be considered the amount of force that we are applying on something, how far we pull it, and how fast or how long it takes us to do that. So how far we go in a given amount of time. And so here's the example that I want to calculate. It's a little bit off the wall, but it's something pretty cool that we can look at. So we're going to look at a dog sled team here, and it says that a dog sled dog can generate about 90 newtons of pull. So newtons, remember, is the SI unit. So we're going to be working in the SI system right now. It can generate about 90 newtons of pull at its harness while maintaining a speed of 16 kilometers per hour. How much power does it generate? Never thought about how much power a dog sled dog can generate, but let's calculate that. Now, when we do this, remember we had this relationship up here, this fundamental relationship, that power is equal to the force that I'm applying over how far I'm going, the distance, and in what amount of time divided by time. So do I have those numbers here that I could plug into that? Well, kind of, sort of. I have 90 newtons of pull, that's my force. How far am I going? Well, I really don't know how far I'm going, but I know that at that speed, I would go 16 kilometers in 1 hour. So I might be tempted to say, oh, here's my equation. Let's just plug some numbers into it. Let's just say that our power is equal to our force times our distance divided by time, and then we would plug in our force, which is 90 kilonewtons, times our distance is 16 divided by 1 hour, and we come up with some kind of a number, and I'm going to tell you that this is going to give you a wrong answer. So we need to be careful of how we do this. And I'm going to step you through an example of how we're going to work with the units. We're going to look at the units that are on all these numbers that we're plugging into these equations, and we're going to see where we want to end up, and we're going to do some cancellation through fractions as we do this. And this is really important, and we're going to do a number of examples so that we can get good practice at doing this. So again, what is my fundamental relationship? This is it. Power is force times distance divided by time. So I can put that down, and I'm going to start this equation. I'm going to leave myself a little bit of room to the left of it. I'm going to say that my power is my force times my distance divided by my time. Abbreviate it like that. Now, what do I want? Power. What do we say in the SI units? What do we use for power? Well, power is a watt, and 1 watt is a Newton meter per second. I'm going to write this on the upper right-hand corner of this slide and say that 1 watt is equal to 1 Newton meter per second. So if I want watts, the units that I'm after is a Newton meter per second. And what I do is write it to the left of my equation. I say Newton meter per second, and I will often stick that in a bracket so that I know that I'm looking at this as my fundamental unit that I want to get. So I'm after Newton and a meter in the numerator and seconds in the denominator. That's ultimately what I want. This will give me a watt. This is what my watt is. So that is the same thing as a watt. If I get down to a Newton meter per second, that is a watt. That's what I want. So let's go after this now. We're going to put our quantities into this equation like we have in this equation, but we're going to carry the units with them carefully, and we're going to watch what we're doing. Everything is going to be a fraction, so we can cancel some stuff. So let's begin. How do we do that? Well, let's start with what's the first thing here that I need? I need force. What is my force? I've got a force. I've got a force of, so I'm going to say this is equal force of 90, and I'm going to put my newtons on there. I'm going to carry that unit and keep that 90 newtons with me. So 90 newtons, that is my force. Now, this is going to be a fraction. Everything has to be a fraction. So if there's nothing underneath it, I just say that it's over 1. 90 newtons over 1. Okay, so there's the first part of that. Now, what do I have this distance per unit time? Distance per time. What do I have that's distance per time? Oh, I've got speed up here. That's kilometers, which is a distance. Time is in hours. So let's put that on there. So I'm going to multiply that. So that's force times this distance per time. My distance is what? 16 kilometers. So I'm going to make this a kilometers, 16 km, kilometers per hour. So the hour goes in the denominator. So I have 16 kilometers per hour. Okay, so now I take stock of what I have for units. What do I have in the numerator of all my numbers over here? I have my newtons and I have kilometers. What do I want? I want newtons and meters. So the newtons are right. The newtons is what I need, so that's great. I need meters and I've got kilometers. What's a kilometer? Oh, kilometer, kilo. Oh yeah, that's that. All those prefixes and suffixes, the millo and kilo and all that kind of stuff. A kilometer, kilo, means 1,000, so that's 1,000 meters. So what I can do is multiply this by another fraction that's going to have an equivalency of 1. So what I'm going to do, I want to get rid of kilometers. How many meters in a kilometer? There's 1,000 meters in 1 kilometer. So what I do is multiply this by 1,000 meters per kilometer. Okay, now what have I done? I've multiplied. This is essentially, this part of this fraction is essentially 1. 1,000 is the same as 1 kilometer. 1,000 meters is the same as 1 kilometer. So that's like multiplying this number by 1. I can multiply by 1 all day long, and it doesn't change the value of anything. And so that is cool. I can multiply that. It doesn't change my value. But now what I can do is start canceling units, because look what I have. I have a kilometer in the numerator over here and a kilometer in the denominator here. They cancel themselves off. So I'm going to just put a slash through them because they cancel. Now, what am I left? I'm left with a newton in the numerator, which is what I want. The kilometer is gone, and I'm left with a meter in the numerator. Hey, that's what I want. I got my newton meter. What about the bottom? What about the, oh, shoot. I need seconds, and what do I have? I have hours. Oh, okay, so I've got to have something to convert hours to seconds. How many seconds in an hour? Well, you can look that up. You might know that. It's 3,600 seconds per hour. But we can do this in steps. This is kind of cool. So I don't know how many seconds are in an hour. I know how many seconds are in a minute, and I don't know how many minutes are in an hour. So let's do this sequentially. We can say, okay, I need to get rid of the hour, so I'm going to multiply this by some fraction that has 1 hour in the numerator. That's going to cancel that hour off, and I know that there are 60 minutes per hour. So what I have done then is taken 60 minutes. 1 hour is the same as 60 minutes, so top and bottom are exactly the same amount, so that's like multiplying by 1, so I don't change the value of my number or my equation or anything. But now I've gotten rid of those hours, so the hour is gone, and I've got minutes. Okay, I still need to go one more step because I need to get down to seconds, so I need to get rid of the minutes and give me seconds. So, I just do this again. Okay, I need to put minute in the numerator, 1 minute, because the one I want to get rid of is in the denominator, it's in the bottom. So I say 1 minute for every, how many seconds are in a minute? There's 60 seconds in a minute. The minutes cancel off. Now what am I left with? Look at my numerator. I'm left with newtons right here. I'm left with meters right there. All the other units have been canceled off. In my denominator, the only thing I have left is seconds. Oh, that's what I wanted. That's what I needed. I needed Newton meter per second. That's all I have left. Everything else has been canceled off. But now look, I've got this big long train of extra numbers here. This was my fundamental equation. These two pieces right here was my fundamental equation, and I've got all this extra stuff over here. What's all that extra stuff? Those are conversions to convert units to what I want them to be the proper number, so it comes out correctly. So mathematically, now how do I handle this? Now I get my calculator out, and I multiply everything in the numerator, and I divide everything in the denominator. So it would look like this. I would take in my calculator 90 times 16 times 1,000, and that's times 1, so those don't matter in a calculator. So 90 times 16 times 1,000, that's all the numbers in the numerator in that whole train, that whole string. Then I go to the denominator and I divide. So after I get all those multiplied, I say divided by, come down here, 1 doesn't matter, come across, that's another 1, that doesn't matter, 1 doesn't matter. Oh, there's a 60, so I divide by 60. And then again, I divide by 60. And that's going to give me my correct number. So my number, this answer, would come out to be 400. 400 what? What are the units? Newton meter per second. Okay, that is my units. Okay, what is a Newton meter per second? We said, oh, a Newton meter per second is a watt. It's the same thing, so that's a watt. So I can really rewrite this as 400 watts of power. That's how much power that dog sled could generate if those numbers are correct. Okay, so that's how we do that. See, now here's where again, and we're going to do some more examples about this, but if I would have just taken these two numbers, 90 times 16, multiplied them together and give me a number, it would not be this number because I missed the 1,000 and the 60 and all those things that had to be in there to convert those units. So that's why we start with this basic relationship. Put the numbers in and then watch the units. And when you get to the end, if you've got to fix any units, you fix the units, then you're always going to come out with the right number. So this is really important and something that we've all got to really focus on and learn how to do. So now I'll do one more thing. 400 watts, to a lot of us that grew up in the U.S., we don't understand watts. Maybe it doesn't make a whole lot of sense to us. So how many horsepower is that? Well, let's convert it. So we can also say, so this is 400 watts. We can also say that this is watts and kilowatts. So there's 1,000 watts in a kilowatt. So basically, to go to a kilowatt, I'm going to take my decimal point, which is right here, and I'm going to move it to the left 3 places, which means I'm going to divide by 1,000. So what I can say here is that this is 0.4 kilowatts. So that is what my kilowatt rating is. Okay, same thing, just changing from watts to kilowatts. It's really simple, just dividing by 1,000. But I'd like to know what horsepower is. Okay. So let's say, what is a horsepower? So I'm going to put that up here in the upper right so that we know what it is. The 1 horsepower, and this is a conversion that you can look up. Yeah, let me do this carefully. 1 horsepower is equal to 0.746 kilowatts. That's a conversion. So that's just a number that we look up that's converting from kilowatts to horsepower. Okay, so I can use this now. This relationship, 1 horsepower is the same thing as a kilowatt. I can use that in my whole fraction deal like I have been doing along here to convert this to horsepower. So what I can do is say, okay, this is really like a fraction, 0.4 kilowatts. We can say that's over 1. And I'm going to multiply that by 1 horsepower is equivalent to, or is the same thing as, 0.746 kilowatts. Right there. So if I take That's going to cancel off my kilowatts down here. So the kilowatts and kilowatts are canceled off. I left with just horsepower. So if I put this in my calculator and say 0.4 divided by 0.746, and this is going to tell me that my horsepower rating for that dog is 0.54 horsepower. So basically, that dog sled working and pulling on that team is like a little bit more than a half a horsepower. So if you count up the dogs, however many dogs you have in a sled team, you can start guessing how many, what the equivalent would be. How big of an engine would that be like on that dog sled? So it's kind of neat to be able to look at that, but this is linear power. Again, the key thing that we want to watch is that we don't just start chunking numbers into these equations and getting a number out and assuming that it's right, because there's a good chance that it's not. There's a good chance that those units are messed up. Keep track of those units. We'll do some more examples here of rotational power to illustrate this, to illustrate how we come out with the wrong answer.